Are you recording?
Oh, great. Great. Well, thank you so much. I'm excited to be here and to talk to you a bit about tidycode. I think my presentation, it should take between 20 and 30 minutes, so we'll have a good amount of time for kind of some questions at the end, and then I can try to stick around too if there are kind of more questions even after that as well. But here we go. So you can find these slides and the slides from other talks that I've given at lucymcgowan.com/talk if you'd like to either follow along now or you want to see them later. I think it sounds like Margaret mentioned you guys have a nice repository for slides, and so you can also get them there. So there's lots of ways that you can find these slides going forward. So this is all joint work with Jeff Leek and Sean Cross. As Margaret mentioned, I was a postdoc under Jeff Leek. And so this was part of what I did as my postdoc, and then kind of going forward, we've extended things a bit. And so just a thank you to the Leek Lab at Johns Hopkins for, they also contributed. We, as part of actually, Margaret and maybe Stephanie too, that we were trying to get crowdsourcing kind of different pieces of this package that the Leek Lab in particular put a lot of effort into helping with. And so there's just wanted to thank them for that as well. Okay, so the big picture here is we want to analyze basically how analysts are coding. So we've got this like kind of meta idea here. And why might we want to do that? Well, I'm sure that other people could think of other reasons, but the reasons that motivate me at least are to be able to facilitate data science pedagogy. And so as Margaret mentioned, I am really interested in kind of best practices for teaching statistics and programming and things like that. And so being able to just look at kind of how people are understanding things so far and how they actually code, I think can help inform how we could maybe teach differently, or if there's something that's working, teach the same. This also can help with reproducibility and replicability. So to be able to sort of quickly analyze a chunk of code or a script or something like that can kind of help us understand which pieces kind of cause the most differences between analysts in terms of being able to replicate a result, for example. And it also can just be used as a way to explore how current software or tools are being used. So, folks, for example, at RStudio are interested in how people are using their packages. And so they can use a tool like this to be able to sort of scrape like maybe all of GitHub for people that call a certain library and see which functions are being used most commonly and things like that. So that's kind of the why behind what we've developed here. And if other people have other ways that they think this could be useful that I haven't mentioned, I'm always excited to hear about those as well. So then there's also the how. And so the how is, there are actually two packages that I'm going to talk about because they are really interlinked. There's a package called Matahari, which Sean Cross was the primary developer on and I've been contributing to. And then there's the tidycode package, which we've done in collaboration. And so here's kind of the big picture. We've got R, and you can kind of write R as either static R code or dynamic R code. And we can kind of funnel that code through Matahari to be able to stick that into something that is machine readable. So you can take that code and kind of put it into something that, well, not just is machine readable, but is kind of like data analyzable. So in a tidy framework. And so that basically puts either that static R code or that dynamic R code into a nice data frame that you can then analyze. And so once it's in this tidy data format, which just to kind of iterate what we mean by tidy data. So this is kind of, it's something that I think Hadley's team has really pushed in the tidyverse space at RStudio, but it basically means that each variable has its own column, each observation has its own row, and each value has its own cell. So thinking about that in terms of R code, you could imagine that each column kind of corresponds to something like what was the function that was run or the expression that was run, what was the output from that, what maybe were the errors from that, and so on. And then each observation could be something like a line of code, or it could be a single expression of code. And then each value would be kind of a value for each of those. So that's kind of the pipeline that happens on the Matahari side. So you can take an input of either static code or dynamic code, put it through this Matahari package to get this nice tidy data frame. And then the tidycode package comes in as the ability to sort of analyze that tidy data frame in a way that you could generate reports to be able to look at things like I mentioned before, sort of like how people are analyzing data, or to be able to look at which functions are being used in what way and things like that. And so the analogy that we sort of draw and kind of where we got a lot of inspiration for the API for tidycode comes from the tidy text package. And so this sort of the text is to tidy text as code is to tidy code. That's kind of the analysis there. I guess these types of analogies like X is to Y, I feel like this used to be like on SATs and it's not anymore, but hopefully that's still a relevant way to describe kind of comparing things. But basically, instead of analyzing elements of text, we're analyzing elements of code, but we're doing it kind of in a tidy way where the expectation is that it's coming in a tidy format to facilitate that analysis. And so the tidying process itself is happening via Matahari, and then we're doing the analysis via this tidycode package. And so yes, instead of analyzing tokens of text, we're analyzing tokens of code, which is kind of the jargon, the tokens sort of being the jargon that's used often in text analysis space. And so similarly, in tidy text, there's this concept of stop words. And so these would be words like the or a, or, you know, kind of filler words that maybe don't really add extra meaning to a chunk of text. And the same in tidy code, we have something called stop funcs, which are like stop functions, which would be things like, for example, an assignment operator or a pipe, or things that maybe you might want to exclude from your analysis, or maybe not. So the way that we have this set up is there are some default stop functions, but you can pass your own list of functions that you'd like to kind of exclude from the analysis. And that can be updated accordingly, because maybe sometimes what we've considered a kind of word that would, or a function that would be stripped away from the analysis would be actually the purpose of whatever analysis you might be doing. And so, yes.
We have a couple of questions, Lucy.
Oh, great.
Do you have
I love
a moment?
Questions. Yeah.
Okay.
Perfect.
So one person was asking what the difference between static and dynamic code is.
Oh, that's a great question. And maybe I've sort of like made up those, so maybe I'm not using them in a way that's intuitive, but what I mean by it is like static code would be like a .r file or a .rmd file, for example. So code that like exists in a document. And dynamic code would be like you're typing in your R console dynamically. And so both of those can be captured by Matahari. The static code or the file, basically you would just pass the file name and it can turn it into this nice tidy data frame. The dynamic code, you would basically you'd cue Matahari that you'd like it to start recording. And so you would cue that up and it would kind of record everything you dynamically type into the console. And then you could cue that you'd like it to stop recording and it'll create a nice tidy data frame of everything that was dynamically typed.
All right, and then another question was, can you tokenize different parts of the code similar to tokenizing words, e.g. n-grams?
Yeah, that's a good question. So you can, but we still have like, there's definitely functionality that could be more, that could be revealed to the end user a little bit better. So like if you dig into our functions, you definitely could look at things by line. Or so just to sort of define what this means for folks that maybe aren't as familiar with some of the terminology, to tokenize like so I said here that a token was, I just said code, which sort of was vague. And in our case, often the token of interest is the function. And so what that means is that like each row is going to correspond to a single function that's called, and will also include kind of an indicator for what line that function was called on. So if you're doing it dynamically, a line basically means when you type something out in your console, when you're doing it in a script, it means like an actual line of code. But you could, like in the tidy text frameworks, I think tokenizing on a function is sort of similar to to having the word be the token. You could imagine instead having the sentence be the token, or like the whole line of code being the token, which is possible, but I don't know. It's not actually revealed to the end user. You'd have to dig into some of our functions to get to it, but that's a really great question. And then even further, you could imagine the token being like a chunk of code that is supposed to do a certain task. And so I'll show in a little bit how part of this package has the ability to classify code. And so you could imagine like starting by tokenizing down to the function level, but then kind of classifying chunks of text based on the most prevalent what like a certain set of rows is most prevalently classified as. And so I guess I don't know that I totally answered the question of whether it is possible to have different tokens, but it's not very easy with the way that the API is now. But that's definitely something that if there was broad interest could be added.
Great, thanks, Lucy.
Yeah, are there other questions?
That was it for now.
Okay, yes, thank you.
Unless other people have questions, but that was what was in the chat.
Okay, yeah, I'm happy. Please either put them in the chat or just unmute yourself and ask me if you have questions. I'm happy to answer as we're going along here. Okay, so yes, so instead of removing stop words, we're going to be removing stop functions, and these basically are just a way to strip away things that would maybe be superfluous when you're trying to analyze kind of code. So another example might be like the plus sign. If you're analyzing a bunch of ggplot code, you don't really need to know that they had a whole bunch of pluses in between each of your lines, and so you could strip that away from your analysis. And so the next kind of analogy between tidy text and what we're doing is sentiment in tidy text is similar to basically analysis tasks in tidy code. And so basically instead of classifying text by sentiment, and so often in text analysis, the simplest way would be to just classify text as positive or negative, for example. And the way this is done is there are these kind of data sets, large data sets of words where these words are classified as either positive or negative, and those are merged into your tidy data frame to then classify the words that you have in your data frame as such. And so in the tidy code framework, we instead classify code by analysis task. And by code here, I mean individual functions. And so on the function level, we are classifying these by kind of a set of analysis tasks that we pre-specified as potentially of interest. And so the analysis tasks that we've picked are the following. So setup, which we take to mean things like when you're calling your library, for example, at the beginning of your code, kind of things that just set up the remainder of the analysis. And then we have exploratory. And some of these can be interpreted kind of a little bit differently, which makes some of this somewhat difficult. But by exploratory, we often mean things like maybe plotting, but like before you're doing an analysis itself, or maybe doing things like looking at different summaries of data in different ways to be able to sort of assess whether or not, to explore kind of missing data or things like that. And then we have data cleaning, which would be actually cleaning your data. Modeling, that one's relatively easier to sort of pick up because maybe you're using tidy models package, or maybe you're using like a common R function for modeling, like the LM function or the GLM function. And then evaluation, which would be then taking that model output and evaluating kind of things like an ROC curve, for example. And then post visualization. So this would be like after you've done your analysis, then you could visualize the results. So maybe this is a forest plot of the coefficients that you get from your model. And then there's communication. And then finally, import and export, which would be like import would be things like read CSV, export would be things like write CSV. So this is these are the tasks that we've sort of picked. I think that they could be, you could argue for a different classification, but this is sort of where we landed when we started this, and we've just kind of trudged on with it. And so from these classifications, we've basically built lexicons. We have 2 that are currently available via the package, but you could build your own lexicon either within your group or personally, or kind of for whatever purpose you might have. And so when I mentioned before that the kind of sentiment analysis in the kind of natural language processing world, or in the kind of tidy text space, consists of these data sets that have tons of words in them, where these words are classified in a certain way. Those are called lexicons, and lots of different people have created lots of different versions of these that you can import and then merge into your data. And so we've sort of done the same thing here. The Leak Lab lexicon, as I mentioned, the Jeff Leak's lab did a lot to help us early on, where they basically, folks looked at a bunch of our code and classified individual functions into each of these categories that I just mentioned. So they did this basically by hand. A whole bunch of folks in his lab kind of helped by doing this. And then we also have a crowdsourced one where we created an application that could do this kind of quickly, where people would see a function in R and then classify it. And we promoted this via Twitter and other kind of social media platforms, and we're able to get several people to help with that. And so this crowdsourced one, it looked something like this, where we basically tried to turn it into a game. So we had this this app that said, help us classify functions from data analysis R scripts into categories. And we essentially, you could create a username, or you would, if you didn't want to use a username, we would make one for you. But that would let you kind of log back in. And on the back end, we had scraped a whole bunch of .r files from GitHub, just sort of randomly sampled from the world of GitHub. And we showed the user one function at a time. So when they signed into the app, they saw this little game where they would get a coin for every function. It's interesting because this did actually seem to motivate people, even though there's like nothing real behind it. But you would get this little coin every time you classified a function, and then you would get a rank. And so, and there was a little hall of fame for kind of the top people. And you also could upload your own .r file if you had some that you thought you wanted to classify, instead of using the GitHub ones that we had. And so code would appear in this little black box, and you could select the class that you thought that code fell into. And so then we would actually.
Questions. Sorry, we have a couple of questions.
Oh, great.
Is a lexicon analogous to a corpus in text analysis?
Oh, yes, I think that's probably true. Well, no, maybe not. A corpus. So sorry. I said yes and then no. I think I'm not totally well versed in all of natural language processing, but a corpus sometimes I thought would refer to like a entire book. Is that right? Does anybody know? Anybody else? Like, I thought that a corpus could be like if you had all the text from all the Jane Austen books or something, that could be considered a corpus, which would be sort of different than a lexicon, which would be like a classification specifically of individual words in just individual classes. But I might be misdefining corpus. So
yeah, so it says, so when a linguist is chiming in the comments saying that a corpus is a collection of text or spoken language. So it's a collection of things.
Okay, that's
all the
what
data.
I was initially thinking. Yes. So I think a corpus is more like all of the Jane Austen books, maybe, or something like the actual text from those books. Whereas a lexicon would be like if you took the unique words from that text and then classified them in a certain way. I think that at least the lexicon as I'm using it here, that's what I mean.
Okay. Yeah. And then there were another couple of questions. It would be a two-way function analysis task classification. Also, what is the API here exactly? So I'm not sure what the first question is asking.
Yeah, I'm not either.
Oh, I see. I guess you're classifying the function and the analysis task sort of together, I think.
Yeah, what I meant was the same function could be, there would be different functions for the same analysis task.
Yes.
So it would, so would it be a two-way classification kind of, I mean, like a two-way matrix? That's what I meant actually.
Yes, this is a good question. So, and there could be multiple, so the way that we do this, you can do it multiple ways, but right now, if two different people kind of classified the same line of code as two different tasks in this lexicon, then it ends up resulting in two rows in our data frame of lexicon. So just to give some context for what that data frame of lexicons looks like, it's got like a row for function and then a row for classification. And so, for example, I mentioned like plotting could be both exploratory and in the visualization kind of class. And so if ggplot, if someone said that a certain ggplot function was classified as a visualization and someone else said it was exploratory, both of those end up as rows in this data frame, and the prevalence of each ends up in there as well. And so you can basically subset that to just take the one that most people have classified it as. So for example, most people classify ggplot as a visualization rather than exploratory function. And so in that case, it's going to take that, or you could merge it in and include both, and then you would you could give some weight to each of the different classifications. The other thing, which is not currently possible with what we've done, but has been suggested as a future step, would be that you can add some context. And so right now this goes function by function. But if you had I think we've benefited for sure by building this on top of the natural language processing kind of space, because there's a lot you can do kind of with language that this right now is relatively simple in comparison to. But you could imagine with language, like the most simple tidy text examples are just showing you a single word classification. But then there's this idea of n-grams where like instead of just using one word, you could use a bigram, which would be two words. And so you'd see the word and then the word just before it, for example, and you could classify kind of if that ends up changing your classification, which in this context certainly could. So maybe if I saw ggplot being used in conjunction with a box plot versus if I saw it being used in conjunction with a forest plot, maybe I would classify those differently. And so that's like, it's definitely a possible extension, but it's not something that's built in at the moment.
All right, and then the additional question there was, what is the API?
Oh, API, so API, I just meant like basically by that I mean the code that you would type from my package. And so basically the way that I've set up the functions in my package to work. So it's the interface
it's like
between
like a call, basically. It's a call, I would say.
Like a call. Yeah, it could, yeah, like the call. I think I sometimes use the API to just mean if there's sort of this shared kind of method across, like a consistency across the types of functions that we've created, so that if you're used to the types of functions in the tidy text package, for example, when you come over to the tidy code package, hopefully the names of the functions and the way the functions operate would feel intuitive. And so I guess what I mean is the API between these two, or the names of the functions and the way the functions operate, try to have some consistency so that as a user, it can be a little bit quicker to pick up the language itself.
I see. Thank you so much, Lucy.
Yeah.
All right, another couple of questions. So one of them, Stephanie was asking what happens with narrative text in the static code, i.e. non-code chunks.
Like code, like, I mean,
I guess if it's an R markdown file, what happens with the narrative text?
Yeah, so nothing happens with the narrative text. And in fact, the way that this works right now is it takes a .r file. So you would, there'd be like one step before where if you wanted to put in a .rmd file, you'd have to run it through Perl to pull out the R chunks, and then would just, and comments are just going to get basically stripped away because it's only going to take expressions from, so, and that goes all the way back to how Matahari behaves. Like Matahari will go through your code and just take all of the things that are basically R expressions and stick those into individual rows of the data frame.
All right, and then the last question was whether or not this classification game is still online.
It is, yes, I think it is. Anyways, I never took it down. It'd be at lucy.shinyapps.io/classify. So yeah, you can participate. Although I guess it's possible that it's like broken by now. I haven't actually looked at it in a while, but yeah, this was actually, I mean, we never did anything with this other than collect this data. But I think it could be an interesting, like, further exploration of like, people will help you crowdsource things if you turn it into a game. I'm sure there are like lots of psychologists that like are very familiar with that, but.
Yes, this individual thought it sounded fun and wanted the coin, so.
Oh, well, yeah, they should. Yeah, then go right ahead. You should. Yeah, lucy.shinyapps.io/classify. If it doesn't work, you can let me know and I'll do something to try to fix it.
Great.
Collect
Thank you, Lucy.
my fake money. Yeah. Okay. Are there any others, or should we can keep going?
No, that's it for now.
So I wanted to just give a use case for when we've used this before. And so as another kind of piece of what I did with Jeff as my part of my postdoc was we were interested in sort of thinking about how people analyze data and whether or not there were certain patterns that we could recognize. And so we came up with this P-hackathon data challenge where we basically gave a data set to the users for them to analyze. And we gave them something that a question we were interested in. So we said we were interested in the association between the posted standby wait time for a popular amusement park ride and how many units of merchandise were sold that day. And so the data was somewhat randomly generated, although it started from some data from Disney parks actually. And then we created this merchandise piece ourselves so that we could fix the relationship that was expected to be seen, kind of the true relationship that users would see. And then we told the users using the data provided that they were tasked with finding the smallest or the most significant p-value, and that we would host this leaderboard. And so basically what we wanted to do is we collected some information about these users, and we also looked at kind of the methods that they used to actually p-hack or get these small p-values, and we wanted to see if there was kind of some systematic way that people were analyzing code that led to them kind of getting these really small p-values when they were known not to be there, since we had created this data set and we knew there was no actual real association between the units of merchandise, which was a made-up variable, and the wait time for this popular amusement park ride. So the way that this actually would work is the users were sent to our Studio Cloud when they first joined, and they could type things in. Everything they typed in the console or in an R script was basically recorded by Matahari. So for example, they might fit a model or they might load a package. And so as soon as they were sent to this our Studio Cloud space, the Matahari kind of recording began. And when they finished the analysis, they would indicate that they wanted to kind of turn in their final result, and the Matahari recording would end. And so that Matahari recording basically stuck all of that code or all of the functions that they ran into this nice tidy data frame. And then we could take that data frame, which one of the columns here is going to be the expression, the actual function that was run, and we could pass it through tidycode and we could get some nice reports. And so basically, the expressions here are going to be like the individual pieces of code. For example, if they were running library tidyverse, and then they were taking the data, they were filtering it, and then they were fitting a model, each of those would end up being kind of a line in this data frame. And then it would filter through tidycode so that we could actually analyze it. And so once we had it in this kind of data frame, this DF here, which maps to the DF this is that tidy data frame that Matahari recorded for us of all of the users' functions, we could then use this unnest_calls function, which will take those individual calls, unnest them, and we say the thing we want to unnest is the expression. And so this right here, this unnest function is, when someone was asking before about if you wanted to tokenize by something different than expression, kind of how you would do that, this function is going to be you would be putting in a different input, but it's not super easy to do that at the moment with the way that our package is. But that would be kind of the analogous piece to how that would work in our package relative to how like the tidy text package works, for example. And then if we wanted to actually do some kind of classification of this, we would take that data frame that now has these unnested tokens. And so I've called that, and so that's this TBL here is that table of unnested expressions. And I would pipe that to the anti-join, which is going to basically remove any functions that I don't want in there. And in order to do that, here I'm using the default get_stop functions. And so this is a default list of stop functions, or functions that we thought maybe people would commonly want to remove, things like the plus sign and different sort of like filler pieces in code that don't necessarily tell you exactly what task someone is completing. But as I mentioned before, you can just pass your own list of stop functions here if you'd like. And I guess I should actually pause. I'm realizing I use pipe terminology here, which not everybody is familiar with. And so just to give everybody sort of a sense of what this means, so the pipe is basically a way to take the thing that you are piping, so the thing on the left side of the pipe, and you stick it into the first argument of the thing it's piping into on the right side of the pipe. So for example, this data frame here, TBL, if I pipe it into the anti-join function, that's equivalent to me saying like anti_join and then TBL comma get stop funcs. And so essentially it just sticks whatever is to the left of it into the first argument of the next piece. And so often people say something like and then when they're doing the pipes, because it kind of describes the process by which you're running functions in R. So instead of kind of having a bunch of nested functions, it lets you sort of talk about it linearly, which I think is a nice feature. So I take my tibble here, my data frame that has my tidied expressions that have now been unnested, and I anti-join the stop functions, which means I remove all of those from that data frame. And then I do an inner join. And the thing I want to inner join with is my lexicon. And so to do that, I use the get_classifications function. So this is going to pull my lexicon. And you can specify which lexicon you want to use. So that's going to be the first argument here. Here I'm saying I want to use the crowdsourced lexicon. And then you can indicate whether or not you want to include duplicates. And so this gets to the question we had before about that multiple functions could be classified in multiple ways. And so here, if I say include duplicates equals false, it's going to just include the most prevalent classification for each function. If I didn't have that, if I was saying include duplicates equals true, then it would include multiple lines for each function, where each line corresponded to how people had different individuals that classified it, and there would be a prevalence column that would tell you like 80% classified this function as visualization, and then maybe 20% classified it as exploratory, for example.
Lucy, we had a question.
Yeah.
I think it was actually kind of related to the previous slide too, but
Okay.
Why do you use unnest calls? What is it doing, I guess?
Oh,
exactly?
okay. So what this is doing right now, the way that the data frame is here is the expression column is basically, it's a list column. That's how Matahari works, which means that each element, each row corresponds to an element of a list. And each of those lists is the actual R expression that is run. So you could conceivably rerun that if I just kind of pulling that out and running it in R. And so instead of doing that, we want to unnest that so that it's not a list. We want to just pull out the kind of top level function there. And so that's what this is doing. It's pulling out, like for the first row, like in the example here, where this library tidyverse. So the very first row here is going to literally be library tidyverse, that expression. The second row is going to be this here. The third row is going to be this here. And so what we're doing is now we're going to pull out, for that first expression, we're going to pull out the function library from it, and we could save this tidyverse, like what arguments were used there, and those are preserved if you're interested in the arguments, but it basically just pulls out the top level function. And like this one is going to be more complicated because the top level function is actually filtered based on how the pipe works, and so that gets pulled out as the function, and the arguments are data and miles per gallon less than 20. And then this one is going to be similar. The top level function is going to be LM, and then you have the arguments for the individual, the actual kind of formula, as well as what data was passed. And so the unnest basically is taking those expressions and turning them into, I just want the function, and then I want to stick everything else in a different column.
Great, thanks, Lucy. That was it.
All right, and so then we can take this, and this is kind of less interesting code, but so I'm not going to go kind of line by line through it, but just to show you sort of what we mean by putting this into this format so that it's easier to be able to actually analyze. You can take that classification data frame that we just created, and so at the end of all of this, basically I'm taking my initial data frame that has those unnested calls in it, and I'm getting rid of those stop functions, and I'm joining in the classification information so that each row now has the most likely classification pinned to it, and I've saved that thing as this data frame called classification table. And now I can take that and do some data science on it. And so, for example, this is basically using dplyr to do a bunch of different things like group by certain, in this case, analysis job. And so we were interested in, if you were an analyst by trade, were you more or less likely to kind of analyze things differently or get the smallest p-value in a different way? And so we could group by that, and we could summarize, we can mutate, and so forth. So basically you can apply some kind of data cleaning or data munging. I guess it's not really data cleaning, yeah, some data analysis process to that. And then you can also apply things like ggplot. So once you've sort of condensed that data, you could then plot it in some way. So for example, here we make a bar plot. And so this looks something like this. And so basically here we were looking at the average percent of folks who the participants who conduct analyses as part of their job. So what sort of trying to get at a proxy for whether or not you're a data analyst in some way. And so those who weren't, we can look at the average percent of each classification that they had in their code versus those who were. And so there's a couple kind of, none of this is like particularly scientific. This was actually, we didn't have, the pilot study didn't have a huge sample size. And so there's nothing here that's like statistically compelling, but there's some that you could just for kind of example purposes can give you some idea of the types of things that you could do with this package. For example, it looked like people who didn't do analyses as part of their job spent a lot more time on the setup than folks who did do analyses more often. And then conversely, folks that did analyses more in their jobs, they spent a lot more time on the modeling step than folks who did not. So this darker blue is much bigger there. Similarly, folks who do analysis as part of their job spent a lot more time on the exploratory step than folks who did not. So that just sort of gives some idea of how this could be used kind of in the wild or in practice. And so this is sort of like the big picture of kind of what we've talked about so far, but this is the schema that we've drawn that actually mimics a schema that comes from the tidy text space to sort of try to give some sense for how these things are linked. But basically, starting with either static R code, so either a .r file or a URL or a character string, you can, these are the functions that are associated with kind of each of the packages that let you take those and turn that into a set of tidy R calls, or if you have dynamic code, how you can do that as well with this dance start, dance stop, and dance tipple from Matahari. And then you take those tidy R calls, and as I mentioned in the code before, you use this unnest calls function to get this into tidy R functions and arguments. And then you can do different things. For example, you can classify the code. You can also kind of use dplyr to basically manipulate that data frame. You can summarize that code in different ways. And then finally, you could visualize it using something like ggplot. So this sort of cycle of what you might do with these functions, and then the functions that go along with each piece of those, kind of to give some sense of how this fits into the potential data analysis pipeline. And so we have a paper that highlights this and shows kind of more details on how to use this package called Tools for Analyzing R Code the Tidy Way, which came out in the R Journal I think it came out in December. So that's if anyone has any other questions, I'm happy to answer them. There are sort of some next steps on this. I've been working with folks at RStudio they're interested in incorporating some of this into things like Grade This, for example. They have different ways to be able to do this they take, their LearnR their LearnR package, as well as some of their grading packages, basically allow you to take code from users and then do something with it. And so they have interest in being able to sort of use this to analyze code on that end. And so that's something that we're currently working on. And then, down the line, hopefully there are other kind of projects that this can contribute to as well.
Great, thanks, Lucy. One question that just got posted: how do things like do.call get captured?
Those get captured. So I think those are going to get captured in the same way, but I'm not certain. I'd have to check. But my intuition would be basically it would get captured as like in the same way, in the sense that do.call is going to be the upper level function, and then whatever's inside that is going to be captured as the argument. And so you could go down kind of a nested route where you unnest the call and get do.call as the first level function. And then you could do the same to the arguments to see kind of what the next level function is, if that was of interest.
Great, thanks. So let's see. Well, first of all, let's thank Lucy for the awesome presentation. Let's do some applause. Are there other questions? So someone just posted the link to the paper, which is awesome. Thank you for doing that. Are there other questions from the people in the group?
I'm curious, do you have anybody in your group actively developing it, or are you actively developing it, or?
I had a contract with our studio over last semester to work on some of these things that I was just mentioning. And so I'm developing it in that sense. Like they've offered, now there are like 3 different issues that they sort of wanted added to it, or different features that I've incorporated. And then kind of going forward, I think that it's likely that will have some other features along with it. So I'm actively developing it. My team, my lab has only undergraduate students right now, and they are using it so we're putting out a study in the next couple weeks to try to look at kind of different methods for teaching R and how that might influence people's confidence and things like that. And so they're gonna use tidycode to analyze the data, but they have not yet contributed to the package itself. But it is currently under development, and definitely taking feature requests if people are interested.
Cool, thanks. Other questions for Lucy? Okay. Well, yeah, thanks again, Lucy, for that awesome presentation. I don't know if people have other things they want to chat about while we're here. Thanks for all your nice comments and in the chat. Are there other things? I don't know. Like I said, everything is available on the Our Ladies Baltimore website. If you go to the Getting Started document, you can find the materials that were discussed today, and you can find past meetups. If you go to our meetup page, you can see the next sessions that are coming up, as well as in the slides that I presented today, which are also on our website. So if you're interested in joining us, like I said, we're also interested in potential additional presentations later on this spring. In May and June, we don't have anybody right now. So if anybody would be interested in presenting or suggesting ideas, we'd be happy to hear from you for sure. I don't know. Otherwise, I guess that's it. I mean, I'm happy to hang around here. I'm sure Lucy can hang around for a few minutes too, if people have additional questions that they want to ask. Thanks everyone for joining. We're really happy to have such a big group, and yeah, people from all over the place. And hopefully we can see some of you again next month too.
Thank you for having me. This was fun.
Oh, thanks so much.